Okay, so let's look at some examples. First example, sum n equals 1 to infinity of minus 1 to the n minus 1, 2 to the n over n factorial. Second example, sum n equals 1 to infinity n to the n over n factorial. Third example, sum n equals 1 to infinity minus 1 to the n times n over 5 to the n. Fourth example, sum n equals 1 to infinity minus 1 to the n over n squared. So, use the ratio test to test the above series for convergence or divergence. And say, so if the test is inconclusive, say so. Okay, so if we look at these examples, we can see there are quite complicated algebraic objects in it. So take the first example. We have an n factorial. What is n factorial? N factorial is n times n minus 1 times n minus 2, and you keep multiplying down the numbers until you get to 1. Okay, so the behavior of this series is going to be pretty complicated. So the ratio test is going to prove invaluable when trying to determine whether these type of series converge or diverge. So let's start working through the solutions. First problem. So what was an in the first problem? An was minus 1 to the n minus 1, 2 to the n over n factorial. Now I want to use the ratio test, so that involves an plus 1. So what would that look like? Well, we just replace every n we see in the expression for an with an n plus 1. So we get 2 to the n plus 1 over n plus 1 factorial. Hence, remember we want to look at this limit L, so lim n goes to infinity, absolute value of an plus 1 over an. Now if I want to look at dividing by an, I can look at multiplying by it flipped. So lim n goes to infinity, absolute value of an plus 1 times 1 over an. So when I'm filling in, I'm just going to invert the expression I have for an. So lim n goes to infinity, absolute value, filling in for an plus 1, we just have minus 1 to the n because the plus 1 and the minus 1 cancel. 2 to the n plus 1 over n plus 1 factorial. Times flip an. On the bottom now we're going to have minus 1 to the n minus 1 times 2 to the n under n factorial. Now, we want to see what cancellations we can do. Well, the 2 to the n will cancel with the 2 to the n plus 1, just leave us with a 2. The minus 1s we don't care about because we're taking absolute value. Now, how do we deal with the factorials? So what was n factorial? N factorial was n times n minus 1 all the way down to 1. N plus 1 factorial is going to be n plus 1 times n minus 1, and again all the way down. So the only difference between the top and the bottom, we get all these cancellations, is that on the bottom we have this extra term of n plus 1. So this is equal to 1 over n plus 1. Now I'm going to fill that into the limit. Absolute value 2 over n plus 1. And this is 0. In particular, it's less than 1. Hence, by the ratio test, we got this limit L was less than 1. So by the ratio test, this series converges absolutely. And in particular, it converges. So it converges, not only actually converges, it converges absolutely. So this shows us how powerful the ratio test is. We didn't have to look at the limit of partial sums, which is what the actual series is. We just looked at the limit of the absolute value of an plus 1 over an. We established that was less than 1. And from the ratio test, we just get absolute convergence.